Hello everyone, and welcome to this theory recording on capacitor and inductor circuits. So this recording will be focused on the inductor. What is an inductor? An inductor is a passive element that stores energy in its magnetic field. It's made from a coil of conducting wire wound around a core, and the core, which you see in the picture here, can be steel, plastic, or even air. An inductor will have no typical polarity, and the symbol of the inductor will be L. The unit for inductance is henries, and the equation that characterizes the inductance based on the physical properties of the inductor is the equation that's indicated below, where N is your number of turns, L is the length of the inductor, A is the cross-sectional area, and mu is the permeability of the core. There are many factors that will relate an inductor and that are proportional to the current flowing through the inductor. So typically when you think of an inductor, think current. Now, what are the equations that will be important to remember? The first one will be the voltage across the inductor. VL is L di dt. So you see the dependence of the current there. It's important to note here that because the voltage relationship to the current has a derivative, that tells you that an inductor is also not a linear element. Second, the current through the inductor, if you integrate equation 1 on both sides, you'll get a final expression for the current, which is the current is given by 1 over L integral from t0 to t of v dt plus the current at time t is equals to 0. Thirdly, the energy stored in the inductor, omega c, is given by a half Li squared. Again, you see the dependence of current, so a half inductance times the current squared. Number 4, the behavior of the inductor under DC conditions. So like we did with the capacitor, let's evaluate what first the resistance, or in this case impedance, of the inductor would be. So the impedance of the inductor will be j omega L, and under these DC conditions, again we said the frequency tends to 0, so this will be j times 0 times L, which is going to give you an impedance of 0 ohms. And we know that in electrical terms, an impedance of 0 ohms must be a short circuit. So under DC conditions, which would be a constant voltage source or a constant current source, the inductor will become a short circuit. Finally, let's take a look at series and parallel connection. A series connection with L1, L2, L3 all the way to Ln, L equivalent will be just the sum of L1, L2 up all the way up to Ln, similar to series connected resistors. And parallel connected inductors will, the calculation of the equivalent inductance will be the same as that of a parallel connected resistor network. So 1 over Leq will give you 1 over L1 plus 1 over L2 all the way to 1 over Ln. Thank you for watching this video and enjoy the course.